All right, Unit 10 notes, 10.2, add and subtract polynomials. When we talk about adding polynomials, there are two different methods that we can use, the horizontal method and the vertical method. Now the horizontal method is probably the one you're most familiar with, and it just involves combining our like terms and simplifying. So for example, right here, I have an 2x cubed, and then I have an x cubed here. So I have 2x cubed plus x cubed. Next, I'll use my squared term. So I have minus 5x squared, and over here I have a plus 2x squared. So I'm just rewriting this entire thing without parentheses and combining my like terms so they're next to each other. Then I have a plus x, and I don't have any x terms over here, but I do have a constant. I don't have any constants here, so all three of these have been written down now. And then if I put this minus 1 here now, all three of these have been written down. So I should still have 6 terms. 1, 2, 3, 4, 5, 6. And here I have 1, 2, 3, 4, 5, 6. Now I'll combine my like terms. So 2x cubed plus x cubed is 3x cubed. Negative 5x squared plus 2x squared is negative 3x squared. And then I have just a single x, and then a single negative 1. Now I only have one version of each variable. So I have x squared, x cubed. I don't have to have each term, but I do have to have only one of each term. So I can't have two x squareds. I would need to combine those. So this will be my answer. That's as far as I can go. I can't combine any of those other like terms, because I don't have any other like terms. So it just involves grouping those like terms together and then simplifying them. In the vertical method, we are going to align the terms that are common, so the common variable types, the like terms, in vertical columns and then add down the columns. So what I'll do is I'll write my first one right here. So 2x cubed minus 5x squared plus x. Now, one important thing to remember with the vertical method is that you must include 0 placeholders for missing terms. That means if I have a term here, but I don't have that term here, I'll need a 0 placeholder in this one to match it. If I have a term here, but no term here, I have to have a 0 placeholder to match it here. So I don't have a constant term in this first one, but I have a constant term here. So I'm going to put a 0 placeholder at the end here, plus 0. Now I'm going to line up my like terms underneath each one. So I have an x cubed. I have a positive 2x squared. Now I don't have an x term, so under the x term from this first one, I'm going to put a 0 placeholder, so that'll be a plus 0x. And then I have my constant term, minus 1. Now all I have to do is add down my columns. So I have 2x cubed plus x cubed. Well, that gives me 3x cubed. Here I have negative 5x squared plus 2x squared is negative 3x squared. Here I have x plus 0x, which is just 1x, so plus x. And I have 0 plus negative 1, and that's going to be negative 1. Now all of my like terms are combined. I only have one of each of those variable terms, so I am finished. And I can see, since I was using the same operations here, the same polynomials, I get the same answer either way. Here, I just regroup and combine my like terms, and if you'll remember, I didn't have anything to combine that x with, and I didn't have anything to combine that 1 with. Here, I just use those 0 placeholders so that I can add down my columns and line them up properly. Subtracting polynomials works very much the same way. When I subtract polynomials, I again can use two different methods, the horizontal method and the vertical method. Now, subtracting polynomials can be done the exact same way as adding with just one extra step. I have to change all the signs in the terms of the second polynomial and then follow the rules for adding. So I combine my like terms and simplify. So here, what I'm going to do is I'm going to make that a plus, and I'm going to flip the signs of every number in here. So my first term, or my first polynomial, stays the same. So that's 4n squared plus 5. Now I'm going to say plus, and I'll have a positive 2n squared, a negative 2n, and a positive 4. So all I've done is flip all of the signs. And now I'm just adding, so I can combine my like terms and simplify. I have 4n squared plus 2n squared. I don't have an n term here, but I do here. So I have minus 2n. And then I have a 5 and a 4, so I say plus 5 plus 4. And then I just combine and simplify my terms. That gives me 6n squared minus 2n plus 9. And because I only have one of each of those terms left now, I am done. The vertical method for subtraction works basically the same way. We change the sign of each term in the second polynomial, and then we align the terms in vertical columns and add down them. So here, what I'll do, but again, in the vertical method, I need to remember to include placeholders, or include 0 placeholders for missing terms. So I have 4n squared. That's the highest term I have, is the squared term. Both of these are 2 degrees or quadratic equations. So I have 4n squared. And then I have an n term here, but I don't here, so I'm going to say plus 0n plus 5. Now underneath here, I'm going to flip the sign of each one of these numbers and write them right underneath their corresponding terms. So I have a negative 2n squared, so I'm going to put a positive 2n squared. Then I have a positive 2n, and I flip that sign and say negative 2n. And then I take my negative 4 and make it a positive 4. And then I add down my columns. 4n squared plus 2n squared is 6n squared. 0n plus negative 2n is negative 2n. And 5 plus 4 is 9. And we can see that I get the same answer as I did when I used the vertical or the horizontal method. So either one of these methods will get you the exact same answer. Now, the reason that switching the signs works that way is because we are subtracting. So when we subtract a negative, we're really adding a positive. So we add a positive. When we subtract a positive, we're really adding a negative. So we add a negative to n to get our negative 2n here as our answer. So that's my answer, and that's subtracting polynomials.